Hi class, let's continue our lesson. Now we will discuss about the chain rule and the general power formula. So what is chain rule? There are functions that are very sometimes difficult to differentiate due to its, let's say, the exponent is not an integer. Suppose, let's say, the exponent is a one half or one third, etc. Or the the function itself is is complicated in structure. So sometimes we introduce an auxiliary variable, say u, to uh, to make the function convenient to solve. We introduce an auxiliary variable u and assign a relation between u and x, let's say x as the independent variable, and then substitute it to the function itself so that y uh, is now expressed as a function of the auxiliary variable u. And for with that, the differentiation becomes convenient, becomes straightforward. So the chain rule in mathematical sentence is shown in this formula 6. So the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x, where our auxiliary variable u is a function of x. So let us algebraically manipulate formula 6 so that we can arrive at some special, or let's say derived formulas of the chain. So uh, when we write the formula 5 here, I mean this should be formula 6. Sorry. So from this chain rule, we can derive these two formulas that it also helpful for us to determine the values, the derivative of y with respect to x. And also, it is important to note that the from the chain rule, we can derive this relation that the rate of change of y, or the derivative of y with respect to x, and the derivative of x with respect to y are reciprocals. Okay. Now let's proceed to the general power formula. So from formula 5, that is this one, the derivative of x raised to n, formula 5 enables us to differentiate any power of x. By means of the chain rule, we are able to differentiate any power of any function of x. So using chain rule and formula 5, we can differentiate any function raised to a certain power. Okay, so in our formula 5, we solve for the derivative of x raised to n. Now, for the general power formula, we can solve for any function of the derivative of any function that is raised to n. So the general formula is shown here in formula 9. The derivative of u raised to n with respect to x is equal to n times u raised to n minus 1 times the derivative of u with respect to x, where u is a function of x. Okay. Now, there is a special case class where when n is equal to 1/2. It is very common to appear. So it is important to remember this special case. Okay. Now, the higher derivatives. Higher derivatives is simply the derivative of the previous derivative. So the derivative of y with respect to x is itself a function of x and may in turn be differentiated. The derivative of the first derivative is called the second derivative. Okay, and so on. Third derivative, fourth derivative. Okay, so Other symbols, notations are shown in your module. So these are the common notations that we used for the derivatives, higher derivatives. Okay. So the second derivative of a function is the rate of change of the slope of the graph. This is a very important property, class. Uh, Later on, as we discussed the um, curves, we will solve for the maxima, minima, and the points of inflection. We will apply the first and second derivative to solve those properties of curves. Okay. Now let's have a sample problem. So find the derivative of the given function. Okay. Now let's solve this one, class. Okay. Now this is the top under the topic higher derivatives. We are just asked to solve for the second derivative of the function. Okay, so our function y is equal to 2x minus 1 cubed times x plus 2 squared. Okay, now before we can solve for the second derivative, we must first determine the first derivative of the function, of course. So solve for the first derivative. Let's just denote the derivative as y prime. So here, class, we have two functions with a raised to a certain power. We can use all the formulas that we have discussed previously. So we will use here the general power formula. Okay. Okay, I'm gonna show it. So this is the general power formula that we will use. And also we will use the derivative of a product. So ito, we will use this one. And maybe we can use also this one. Later, I will just show you. So, okay, let's solve. So let's use first the derivative of product. So the derivative of a product states that the derivative of the product UB is equal to the uh, first term times the derivative of the second term plus the second times the derivative of the first. Okay. So we have first 2x minus 1 cubed times the derivative of the second, which is 2 times x plus 2 times 1. Okay. Now plus, let's write the second, x plus 2 squared times the derivative of the first, 3 times 2x minus 1 squared times 2. Okay. Now, as you can see, there are common factors of these two terms. So let's just factor it out. What are the common factors? We have 2 and we have 2x minus 1 squared. What else? We have x plus 2. Okay. So, ano na lang natitira sa first term? So, ito, since cube to, meron pang 2x minus 1. And 2, ito na, ito na. Okay. So, plus. Dito naman tayo sa second term. We have 3. May natitirang 3. And since square to, may x plus 2 pa tayo. So, yan, okay na. Now, let's simplify. Y prime equals 2 times 2x minus 1 squared times x plus 2. This must be 2x plus 3x is 5x minus 1 plus 6. We have plus 5. So let's factor out the common factor 5. Y prime is equal to, this becomes 10. 2x minus 1 squared times x plus 2 times x plus 1. Okay. Now this is the first derivative. Now, next, let's solve for the second derivative. As you can see, class, we have three function of x, and this falls under this formula. We can use this formula, the derivative of a product, to solve for its derivative. Okay. So our second derivative is equal to, since 10 is a constant, let's just put it outside. So first, the derivative of the first term. So let's copy first the second and third. X plus 2, x plus 1, we have 2, 2x minus 1 times 2 plus, now for the second, we have 2x minus 1 squared, x plus 1, and 1. And now for the third derivative, let's copy the first and second, 2x minus 2, 2x minus 1 squared times x plus 2 times 1. Okay, now let's factor out the common terms. So, ano ba ang mga common dito? We have 2x minus 1. We have 2x minus 1. Okay? Ano pa ba? Wala na, yun lang. So, let's simplify. Let's distribute the terms. Okay, here we have 4. And here, ito na lang natitira. X plus 1, yan. X plus 1. So, we have x squared plus 2x plus x plus 2, okay? Then we have plus 2x squared plus 2x minus x plus 1, okay? And also we have factor out yung 2x, yung isang 2x minus 1, so meron tayong 2x squared din plus 4x minus x minus 2. Okay, now let's simplify. Combining like terms, we have 2x minus 1. This would become 4x squared plus 2x squared plus 2x squared, 8x squared. So this is 3x times 4, 12, plus 1, 13, plus 3. So we have 16x. 4 times 2, 8. We have a mistake here. This should be minus 1. Then, so we have 8 minus 1, 7 minus 2, 5. So we have 5. So this is our second derivative. So that solves our problem. Okay. Now let's move on to the next problem. So what is our next problem? So we have find the slope of the curve at 4, 3. Okay. So here we have a function of x, a term, an expression that is raised to 1/2. So we can use the chain rule in this case, but we will just directly use the general power formula, because actually the general power formula is derived from the derivative of x raised to n and the chain rule. So let's use the general power formula to solve for this problem. So remember, recall class that the slope is identical to the first derivative. Okay, so let's solve for the first derivative using the general power formula. Okay, so we have our equation y is equal to square root of 25 minus x squared. Before we solve it, what do you think is the graph of this function? What do you think, class? If we square both sides, we have y squared equals 25 minus x squared, and then transpose x to the left side, we have this one. So this is actually an equation of the circle, but since our given is the this is actually divided into two branch. So our circles, suppose the graph of this circle is this one, okay, this one. But since the circle is divided into two branch, we have the branch that I am saying is y equals square root of 25 minus x squared and y equals negative square root of 25 minus x squared. This is actually the graph of half the circle, or we can say semicircle. So this one here, the graph of this is the upper circle, this one. And this one at the bottom, this the graph of this one is the lower semicircle. Okay. Now going back to our problem, let's get its derivative. So let's write this in a form that is convenient for us. So we have 25 minus x squared raised to 1 half. So using the general power formula, so we have 1 half times 25 minus x. So if we subtract 1 from 1 half, we get negative 1 half times the derivative of u, which is 25 minus x. So we have negative 1. So our y prime now will be equal to, this is actually equal to 1 over 25 minus x raised to 1. So, wait, this is x squared. So actually this should be negative 2x. Okay. So this should be negative 2x. Okay. Now, if we, yes. So this become negative 2x over 2 times the square root of 25 minus x squared. Now, our common factor, we have a common factor 2, so it's cancelled out. So we have negative x over square root of 25 minus x squared. So at x equals 4, our y prime is equal to negative 4 over square root of 25 minus 4 squared. So ilan to? So negative 4, this is 25 minus 16, which is 9. So square root of 9 is 3. So our y prime is equal to negative 4 third. That is the slope of the curve at point 43. So another solution class, since the given point is 43 and the x and y coordinates are known, we can just square both sides of our function and then proceed to differentiation. So if this is our function, 25 minus x squared, let's square both sides. We have y squared is equal to 25 minus x squared. Then perform the derivative. This is actually your next topic. That is the we can implicit function. But this is not implicit. Y can be explicitly expressed as a function of x. So, but let's differentiate this one. We have 2y, y prime, or if you are not yet familiar, let's denote it by dy over dx is equal to 0 plus is a constant minus 2x. So our slope is equal to negative 2x over 2y, which is equal to negative x over y. And what is our given point? Our given point is 4 third. So our derivative, which is equal to the slope, is equal to negative 4 third, which is the same as the previous answer. So that's how we use the formulas for the derivative of algebraic functions. So I hope you learned something from our module. Thank you.